All right. So, guys, we're starting a new unit, organic chemistry. If you feel the thickness of that packet, it is thick. But we're still spending the same amount of time per sheet. So it's a longer unit. And it's fun. I love organic chemistry. And if you go into college and even just, major in biology, you got to take OChem. And yeah, it's usually the weed out class, so it causes people to maybe rethink their major or not. But everyone who's in this room taking IB Chem, getting exposed to this is huge. So while everyone of your peers in college is going to be struggling, you're going to be the person that, well, you know what you're doing. When I was in college, I spent my time at the library. And my friends were actually all in my chemistry class because we got to know each other so well because we always spent time studying.
Mr. Weaver, were you a partier in college?
I was not. No. It was a huge party college I went to, and they always went to Ybor City. And I'm like, it was University of Tampa. They always had this guavaline thing, and the entire campus was empty. But I was there in the library studying. Yeah! And I passed organic chemistry, so yeah.
I'm sure the fine numbers
All right.
How was Tampa? Wasn't Logan?
Wait, where'd you go?
University. All right, so. Oh my gosh, she's gonna do this on me. So thick, the stable's not working. All right. So, all right, alkane, that's the general name for organic molecules. Organic molecules are anything that are carbon-based. So carbon, remember, has 4 outer atoms, so it has 4 bonding sites, which is the most amount of bonding sites of any atom, unless you're doing an expanded octet. And that's why they have an entire chemistry based around the carbon atom, because it can form so many different molecules. It's the basis of life. Hey, silicon can do the same thing, but not as many things are based off of silicon compared to carbon. Carbon's simpler, so there might be another planet where there's maybe silicon-based life forms, but that's for a sci-fi show. All right, so although alternate name systems are prevalent throughout our studies in organic chemistry, we will name organic substances primarily using IUPAC rules. Anybody know what IUPAC stands for?
International Union of Purified.
Nice. That was a bonus question sophomore year, right? Maybe? No. Wait. Oh, it's right there. Oh. All right. Yeah. International. Wow, I thought you guys. Okay.
Upper Peninsula Air Conditioning.
There we go. International Union of Pure and Applied Chemistry. So, why do we name organic molecules the way we do? Because in 1919, a group of scientists got together and said, this is what we're going to do. That's pretty much it.
I create my own part of chemistry.
So, all right, back in the day, we had different nomenclature. It's kind of the evolution of words in chemistry. So, iron 2 was known as ferrous. Iron 3 was known as ferric. So, you might see that referred to in an old textbook. It'd be really interesting to read a textbook from 1910. It would be totally different. Be like, what are they talking about? Further back in Old Latin, the anion was named first, such as chloridium nitride for sodium chloride. So names have changed. Maybe they'll change in the future, but for now, especially for the IB test, it's going to be the IUPAC. So, all right, alkanes are the bread and butter functional group. It's carbon, carbon, carbon with hydrogens attached to it. And then what we're going to do is we're going to add on functional groups like double bonds, triple bonds, in alcohol, which is an OH, ketone, which is a C double bonded to an O, a whole bunch of other stuff. So we're starting with the basics. All right, saturated hydrocarbon, that just means that the carbons are surrounded by hydrogen. Carbons are surrounded by hydrogen. And they're not just surrounded, they're actually chemically bonded. And then we have a whole bunch of little rules here. So rule number 1 is identify the largest continuous carbon chain. So if you have 4 carbons together, that would be butane. If you got 3, it would be propane. 2 would be ethane, and 1 would be methane. So there's some memorization here. We're going to come back to this. It's going to make more sense if we can just talk about it with examples. All right. So I just threw out a whole bunch of things. Butane, propane, ethane, methane. That's going to be stuff that you're going to want to memorize. So alkane name, if you got just 1 carbon is methane, 2 is eth, 3 is prop. And you always, the functional group of just carbon and hydrogen is ane. So it would be methane, ethane, propane, butane. And that ending can change depending upon the functional group. Pentane, hexa, hept, oct, non, deca. That's as far as we're going to go. But if you're curious, nonane, yep, or nonane. Yeah, we're not going to be doing longer chains than that. So, dodecahedron. Oh, all right. These are prefixes. So, we're going to be using prefixes. So, we're never going to go this high. Usually it's going to be monoditri. Those are the main prefixes we're going to use. That's if you have like 2 carbons coming off of a main chain, you would have 2 methyl groups. So anytime you have a chain, so let's say, here's a chain, 1, 2, 3, 4, oh, what am I doing? There's line angle formula. Let's take a step back. Oh, I have spots right here. Why don't we just, we'll come back to this, because it's hard. Let's throw some examples out there. So molecular formula, let's do butane. So the molecular formula for butane is C4 and H10. So that's my molecular formula. We're not going to really be working with that in organics, mainly the expanded structural, condensed, and then the line angle formula. So expanded structural is what I was beginning to write there. We got 1, 2, 3, 4 carbons, and we're going to have hydrogens attached to these. And I have 4 bonds. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. That's how I know how many hydrogens I need to add, because every carbon must have 4 bonds. And if I count the hydrogens, I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Got my 4 carbons. That's the expanded structural formula. So what if I want to do the condensed? You've probably seen this before. I got CH3, that's going to be one little chunk. I've got CH2, CH2, and CH3. So this is the same type of deal. Line angle formula, that's what I wrote there at the beginning. This is going to be super easy once you get a hang of it. Boom, boom. That's the line angle formula.
For everything?
No, just for butane. So what does this mean? So this edge is a carbon, this corner is a carbon, that's a carbon, and that's a carbon. Every time it bends, and the ends, those are all representative of carbons, and the hydrogens are not written in. And it's just assumed. So this carbon has 1, 2, 3, 4. So there's going to be 2 hydrogens. This carbon only has 1 bond, so it's going to have 3 hydrogens attached to it. This one has 2, and this one has 3. So that's an easier way of writing it once you get the hang of it. So let's do another practice one with an alkyl hanging off of it. That's why I wanted to come back, do that, and then come back here. So these are the main chains: methane, ethane, propane, butane, pentane. But what happens if, let's do a, what do you call it? Not an isotope. Oh, an isomer. An isomer is 2 things that have, 2 compounds that have the same molecular formula but different structure. Isomer. So just for fun, that's the molecular formula, all right? And let's say it looks like this. One, 2, 3, 4, all right? We're going to have H, 3, 6. Okay, yeah, that works out. So I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that's my expanded structural formula. Then to do the condense, I'm going to do CH3, CH, and then if I have a branch coming out, I put it in parentheses. So I got CH3 coming out, and then CH3. So this parentheses is representing this methyl branch. I'm calling it methyl because it's a side chain from the main chain. So that's what these alkyl names are. If you got just one carbon, it's methyl. If you got two carbons hanging out, it's ethyl. If you got three, it's propyl. Four is butyl. But once you get to these bigger side chains, that means your main chain has to be even bigger. So, and we got a practice sheet that kind of represents that. So doing the, I'll just do the line angle formula right here. I've got 1, 2, 3, 1, 2, 3, and then the side chain. And that's kind of what it looks like. 3 H's plus a fourth bond. This center one has 1, 2, 3, and then a fourth bonded to an H. That's why I've got 1 H. 3 H's and a fourth bond. 3 H's and a fourth bond. The ends and the corners are carbons. Does that kind of make sense? Tricky.
What did you say it was in the middle?
So the middle is a carbon. So anytime you got a corner or an end, it's a carbon.
So it's kind of like you're subtracting with the amount of bonds.
Exactly, and what's left over is your number of hydrogens that are connected to that carbon. So like we should have 4 bonds minus 1 that's connected to another carbon. That leaves us with 3 more bonds. So those are with hydrogen, which is what's represented here. Hydrogen, hydrogen, hydrogen. All right. And all right, what happens if you got 2 methyl groups? Well, then it'd be like dimethyl. That's where these prefixes come in. That's why when you go to, you're not going to have these big of prefixes. I think I was just having fun putting those there. So those are the main ones you're going to use: mono, di, tri, tetra, maybe penta. So I think that I skipped something else. Oh yeah. So then talking about the naming. Oh, why don't we name that one? All right. Where am I? Okay. So naming this one, first thing you got to do is identify the largest continuous chain carbon. So actually, like this one was 1, 2, 3, 4. That's butane. So this one we'll write as butane. Well, this one has 4 carbons too, but it's not called butane because the longest chain is 1, 2, 3. So that's going to be propane. Okay, so we're going to name that propane, but it's got a side chain coming off it. So it's not just propane. Propane would be that, where it's just a little mountain. It's going to be kind of like methyl propane. So the number of the chains so that substituted groups have the lowest numbers possible. In this case, it doesn't matter. Like 1, 2, 1, 2. So no matter which way I'm counting, it's still 2. But doing an example like this.
Why was it 3?
Why was it 3?
Yeah.
1, 2, 3. 1, 2, 3. And then there's a side chain.
Oh, that's the side. Okay.
Yeah. Well, I could count 1, 2, 3 and add a side chain. It's going to be the same thing.
So how does it work for something like the one we drew above for C4H10?
This is C4H10 and this is C4H10. This is just regular butane. There's no side chain.
Yeah.
So this is something propane. I got to state the side chain. So the extra carbon is part of the side chain. So just an example right here, I got 1, 2 or 1, 2, 3. I'm going to call this 2-methyl, in this case 1, 2, 3, 4 butane. 2-methyl butane as opposed to 3-methyl butane because 2 is smaller than 3. So I'm going to try to number it. So let's visualize that. 1, 2, 3, 4 or 1, 2, 3, 4. Which is my lower number, 2 or 3? 2. So I'm going to call it 2-methyl butane, not 3-methyl butane.
And you can technically put that outer chain anywhere when you're drawing.
No, I was just throwing this out as an example. This is different. I just wanted to show you an example of that because here I got 1, 2, 3 or 1, 2, 3. It doesn't matter which way. It's both 2. So I'm going to write 2-methyl propane. And that's the name of that molecule, 2-methyl propane. We're going to be spending a lot of time on the naming in formula writing. Although on ID test, they're not going to have questions that say, like, write this name. It's just going to give the organic molecule name, and you'll be expected to know what they're talking about. So indirectly, this is going to be helping you answering the questions. So if more than one of the same substituent group are present, then use the prefixes di, tri, tetra. So let's just throw an example. We did 2-methyl butane, this is, but let's say we have 2 methyl groups. So I got 1, 2, 3, 4. So this is going to be 2 comma. You always separate numbers with a comma, but if you have numbers in a word, you separate them with a dash. So I got 2, 3, 2 comma 3, because I got a methyl group on both of them. And I'm going to do dash, and how many methyl groups is 2? Mono, di, tri, tetra, di, and it's methyl. 2, 3, dimethyl, and then I write the name of the main chain, which is 1, 2, 3, 4. We call that butane. And from here, it's like, oh my gosh, for the longest time I had 3s and 4s mixed up, propane versus butane. So it's just going to take practice and working through it. 2, 3, dimethyl butane would be the name of that. So it's kind of throwing everything together. Multiple alkyl groups, got the commas, got the dash. So then when 2 kinds of alkyl groups are present, they're always listed in alphabetical order. All right, so let's make something else. Let's say we got so I'm thinking I got a methyl group and I've got an ethyl group here, because I'm considering 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Oh, so I accidentally didn't write an example I wanted to, because technically the longest chain is 1, 2, 3, 4, 5, 6, and I got 2 methyl groups. So I'm going to change this up a little bit so I can get my example I want across. We got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So it doesn't matter. They're both going to be the same name, whichever way we consider. So now we got a methyl and an ethyl, and I'm just going to, for the sake of visualizing, 1, 2, I'm going to count them, 3, 4, 5, 6. Or I got 1, 2, 3, 4, 5, 6. All right, so I've got 4 and 3. And 2 and 5. Let's see. Okay, here we go. Oh, this is a good example because I'm at a dilemma. Because we got 4 and 2. Like 3 would be better. I should count this way. But that's not good over here. So 4 plus 2 is 6. 5 plus 3 is 8. Which one's the lower overall number? 6, so the top one. So I'm going to count this way. So I've got 1, 2. Oh, and then which side chain do I name first? Alphabetical order. So I got methyl and ethyl. Which one, M or E, goes first? E. So I'm going to call this 4 ethyl. And then I got to separate letters and numbers with a dash. And then I'm going to do 2 methyl, and this is 6 carbons would be 5 is penta, 6 is hexane, and we put the ending as ANE, hexane. So this is 4 ethyl 2 methyl hexane. And as you can see, the names get longer and longer. And for common molecules, they just give common names, like right here, this is a benzene ring. That's very common. Or if you got something like that, a methyl group, they just call that toluene. Or if you got an OH, they call that phenol. And there's all these different names that pop up for common molecules. Oh yeah, continuing off. So when 2 kinds of alkyl groups are present, they're always listed in alphabetical order. They should be numbered so that the sum of the numbers is the lowest possible. Why do they have all these rules? Well, yeah, because in 1919 a group of chemists came together and decided.
I'm gonna be on that. I think they have
Well, no, that won't be.
One problem I will get right.
Yeah. When numerous branch groups are contained in the molecule, the name of the last group does not need to be separated by a hyphen from the name of the longest chain. So that's just saying we don't need a hyphen here. Just methylhexane together. All right. I forget, when does this class get out?
12:20.
20. We get 40 minutes. This is the first
I
time in a
know.
long time. Huh.
Yeah.
He wasn't even here.
All right. I'm going to let you guys practice these a little bit, and then we'll go over them. All right. So, guys, letter A is mainly a memorization. If you got 1 carbon, it's methane. 2 carbons, it's ethane. 3 carbons, it's propane. 4, it's butane. 5, pentane, and 6, hexane, and so on. Condensed structural formula for pentane. So condensed means we got our CH groups clumped together, CH, CH, and how many H's are with it. So there we go. It's the same thing as this, only with an extra carbon in the center. So this is the expanded structural formula. We want to write the condensed structural formula. So we got CH3, CH2, CH2, CH3. Questions on those? So that can be tricky when you're writing alkyl groups or side chains. What's the molecular formula? All I do is count 1, 2, 3, 4 carbons, and I count the 10 hydrogens. There it is. What is its name? 4 carbons?
Butane.
Butane. All right, what's the condensed formula for 2-methylbutane? 1, 2, 3, 4. 4 carbons because it's butane. And then I got 2 methyl, so I got a carbon hanging off of the second carbon. 1, 2. Or I could do 1, 2. I could do that, or I could put it on the third one. So that is 2-methylbutane. 2-methylbutane. What is the condensed formula for 2,4-dimethylpentane? So what I'm going to do is I'm going to make them... Oh.
They did the same mistake over here.
Ah. All right. So the condensed formula can be annoying, but you can write the condensed formula in Google way easier than the line angle formula. So. All right. So an N carbon is always going to be CH3, and then this second carbon is C, and I've got 1, 2, 3. I need to have a 4th, so that means I got 1 hydrogen. See you later. So it's CH. I'm then going to put in parentheses my alkyl group. And there's just 1 bond, 2, 3, 4, so I got to have 3 hydrogens attached to it. So it's CH3. And now moving on, 1, 2, 3, 4, so I got 2 hydrogens, CH2. And I'm moving on to the last one. I got 1 bond, 2, 3, 4, so 3 hydrogens.
For the second CH.
Oh, this one?
Yeah. Why is there no 2?
Because it's got bonded to this carbon, that carbon, and a third carbon. So there's only one more opportunity for a bond,
And it has a hydrogen.
and it has a hydrogen.
Not the hydrogen.
So if it helps to draw the structural expanded one, you might want to do that to help you out. Yeah. Do you guys want me to show the expanded one, or are we good?
Can you do that for G though?
All right, let's do it with G.
Expanded one, I just-
So pentane, I got 1, 2, 3, 4, 5 carbons because it's pentane. I've got 2,4-dimethyl. Guys, check this out. I got 2,4-dimethyl. So I got my main chain, and I got 1, 2, 3, 4. And it's only a methyl group, so it's only one carbon. If it was an ethyl, it would be 2 carbons. Propyl would be 3. So then I just fill in the rest with hydrogens. H, 1, 2, 3. So I got to have a 4th. 1, 2, 3, 4. Oh my gosh, this is... Now I know why they have the line angle formula there. This is probably one of my least favorite ways of doing it, but you can see everything. You can write the molecular formula, you can write the line angle formula, you can write the condensed formula. So I got CH3, I've got CH only, and then I got to write it in parentheses, a CH3, because this is a side chain, an alkyl group. I got CH2, and then I've got CH, and then again I got to write in parentheses CH3, a side chain, and then I got CH3. And there it is. If I'm doing the line angle formula, 1, 2, 3, 4, 5, it would look like that. All right. Yeah, we only have 2 minutes. It's tempting to close down, but can you guys just want to close down? Or? That is a good segue to end on. You want to
That was
okay.
good.
Well,
Like, I feel confident in what I'm doing.
okay, we'll end on that.